Neptune should have no weather at all. It orbits the sun from almost 4.5 billion kilometers away, nearly 30 times farther than Earth. The sunlight that reaches it is so weak that standing on Neptune at noon would feel like standing on Earth just before night. Its average temperature sits around negative 214 degrees Celsius, cold enough to freeze most gases solid. By every basic rule, Neptune should be calm, quiet, still. Instead, something is tearing through its atmosphere at over 2,100 kilometers per hour, faster than the speed of sound, faster than any hurricane Earth has ever produced, faster than any jet stream, tornado, or storm system ever recorded on our planet. Neptune has the fastest winds anywhere in the solar system, and the closer scientists look, the less sense it makes. So that is the question driving this entire story. Why are Neptune's winds the fastest in the solar system? To understand why this is so strange, you first have to understand how unlikely it is that Neptune has weather at all. Weather is an energy problem. On Earth, the sun heats the equator more than the poles. That uneven heating creates pressure differences. Pressure differences push air around. Push air around long enough and you get wind. That is the basic rule. And Neptune barely gets any energy in. At that distance, it receives less than 1,000th of the sunlight Earth gets. So before scientists saw it up close, the prediction was simple. Neptune should be a frozen, motionless world, a dead blue planet with nothing going on. Then Voyager 2 arrived, and Neptune broke the rules. In August 1989, NASA's Voyager 2 became the first and still the only spacecraft to fly past Neptune. It had already visited Jupiter, Saturn, and Uranus. Neptune was its last stop before leaving the planets behind forever. Scientists expected a quiet blue sphere, but Voyager found movement, clouds, storms, chaos. It found a massive rotating storm system roughly the size of Earth, the Great Dark Spot. It found bright cloud bands streaking across the planet, some moving fast enough to circle Neptune in just over 16 hours. And when scientists calculated how fast the atmosphere was moving, the result did not match any prediction. They were not looking at winds of 200 kilometers per hour. They were not even looking at 500. They were seeing winds exceeding 2,000 kilometers per hour, with some measurements reaching over 2,100. Let that sit next to something familiar. A Category 5 hurricane on Earth has winds around 250 kilometers per hour. Neptune's winds are almost 10 times stronger, not a slightly windier planet, not a stormier Earth. A world producing wind speeds that should not have been possible for a planet so far from the sun. Neptune should have weak, slow, lazy weather. Instead, it has the fastest winds ever measured on a planet. The math does not work. It is like finding a car with no engine outrunning a Formula 1 car. Something else has to be powering Neptune. Something hidden. Something deep beneath the clouds. Uranus and Neptune are often called ice giants. They are similar in size, similar in mass, similar in composition. Both are made mostly of hydrogen, helium, water, ammonia, and methane. Both live in the cold outer solar system, but inside they behave very differently. Neptune releases far more energy than it receives from the sun. Uranus barely releases any extra heat at all. That difference matters, because Uranus is closer to the sun. If sunlight were the main driver of weather, Uranus should be more active. But Neptune, the farther and colder planet, has the stronger winds. That tells scientists the real answer must be buried inside. Neptune also has no solid surface. On Earth, mountains, oceans, continents, and surface features help slow winds down. Neptune has none of that. Nothing for the winds to crash into, nothing to break them apart. Once the atmosphere starts moving, it can keep moving with very little resistance. Layer after layer of atmosphere can slide past itself. And Neptune spins fast too. One day on Neptune lasts only about 16 hours. That rapid rotation can stretch atmospheric motion into long bands, helping create powerful east-west jet streams. So the answer may not be one thing. It may be internal heat, low friction, fast rotation, methane chemistry, atmospheric layers sliding over each other, all working together to create the fastest winds ever measured on a planet. Deep inside Neptune, the pressure becomes almost unimaginable, millions of times stronger than anything on Earth's surface. The gases above compress into exotic layers of water, ammonia, and methane. ices. But these are not ices like the cubes in your freezer. They are materials crushed into strange states by extreme pressure and heat. And one of the strangest possibilities is diamond rain. Methane contains carbon and hydrogen. Under Neptune's extreme interior pressure, methane molecules may break apart. The hydrogen separates. The carbon gets squeezed. And under enough pressure, that carbon may crystallize into diamonds. Not tiny jewelry store diamonds sitting on a shelf, but countless pieces of carbon forming and sinking through the interior like rain, a hidden storm beneath the storm. Above, supersonic winds rip around the planet. Below, diamonds may slowly fall through crushing layers of superheated material. That is Neptune, a planet that looks like a calm blue marble from space, but may be one of the most violent worlds in the solar system. And just when scientists thought they were starting to understand it, Neptune changed again. Decades after Voyager 2 flew past, telescopes kept watching. Hubble, Keck, Lick Observatory, and later, the James Webb Space Telescope. The more they watched, the more Neptune refused to behave like a simple frozen planet. Its clouds changed over time. Sometimes bright systems appeared. Sometimes they faded. Scientists noticed Neptune's cloud cover rising and falling in a pattern connected to the sun's 11-year solar cycle. That was surprising, because Neptune is so far away that sunlight should barely matter. Yet somehow the distant sun still seems to affect its clouds. So Neptune's winds may be mainly powered from within, but the sun may still shape what happens in the upper atmosphere. Then came another discovery. For years, scientists suspected Neptune might have auroras, glowing atmospheric lights, similar to the northern lights on Earth. But Neptune's auroras were extremely hard to detect. Then the James Webb Space Telescope finally found them, and they were not where many people expected. On Earth, auroras happen near the poles because Earth's magnetic field directs charged particles there. But Neptune's magnetic field is tilted dramatically away from its rotation axis, so its auroras appear closer to the middle of the planet, not neatly at the poles. That means Neptune is strange in more than one way. Its winds are strange. Its heat is strange. Its clouds are strange. Its magnetic field is strange. Even its auroras appear in the wrong place. Every time scientists point a better instrument at Neptune, they uncover another reason it does not fit the simple picture. From far away, it looks like a blue ball. But up close, it is a world of hidden energy, violent motion, and unanswered questions. And maybe that is the most unsettling part. We have only visited Neptune once. One flyby. A few hours of close-up data. That is all. Everything else comes from telescopes staring across billions of kilometers of darkness. So right now, completely unseen by human eyes, the fastest winds in the solar system are still racing across Neptune's atmosphere. Clouds are still being dragged around the planet at over 2,000 kilometers per hour. Storms are still forming and fading. The hidden engine beneath the clouds is still running. And somewhere far below, if the models are right, diamonds may still be raining into the depths. Neptune should be frozen. It should be quiet. It should be a dead world at the edge of the solar system. But it is not. It is alive with motion, alive with storms, alive with energy that should not be there. And despite Voyager, Hubble, Webb, and decades of study, we still do not have a complete answer to the question we started with. Why are Neptune's winds the fastest in the solar system? We know sunlight alone cannot explain it. We know Neptune is turning hidden internal energy into terrifying motion. But why those winds reach speeds nothing else in the solar system comes close to? That remains one of the great unsolved mysteries of planetary science. Neptune is not just the farthest major planet from the sun. It is a blue giant hiding a storm engine beneath its clouds. And somewhere, nearly 5 billion kilometers from Earth, the winds are still screaming.